engineering math book. Math book.
You don't?
Yeah.
His book is science.
Yeah, my book is science.
Well, who's your maths teacher?
John.
So tell her you have the wrong book.
Yeah, I told her today in today's class.
Ah, okay.
Yeah, but she said you will give me a new book.
Me?
Yeah, because you are.
She said I would do this.
Yeah.
Did she?
Yeah.
Well, I don't know what she thinks. You tell her,
Yeah.
Stephen said, do your own work. Okay?
Don't say that. They'll be in trouble.
Yeah.
That's her job to give you that book, not my job.
All right.
You tell her I said,
Oh, yeah.
do your own work. Not my job. Alright? She can print it. Alright, simple circuits.
The engineering math is difficult than
Yeah.
science.
Yeah, it is, yeah. Not for you, I'm sure. Easy for you. Yeah. Did you write this down? Simple circuits? Yeah. You got this?
No.
Simple circuits. Okay. So, a couple of things to do. An electric circuit is a path in which electrons flow from a voltage source, and they flow in a closed path called a circuit. Now, you don't, for the, Khalifa, how come you're late? Come on. So, I just need you to write the first two sentences down. Now, before you write it down, I'll just say, the point where the electrons enter the circuit is called the source, and the point where they leave is called the return, or the ground, the earth. The exit point is called return because that's where the electrons finish. So, for example, here in the picture, okay, this is called the source, and this is called the return because the electrons come out here, move through, and then go back in here at the return.
Is that battery?
That's a battery. Okay. Now, for the exam, really you just need the first two sentences. Okay. But I want you to draw this picture. Now, this is called the source. This is called the load. This is called the control, the switch. Source, load, control. What? What?
Just draw this or
Draw this and the first two sentences.
Okay.
It's a simple lesson today. Yeah,
In physics, you don't do practical?
we will. We'll do experiments, yeah.
Second semester.
Yeah.
We're going to DIT.
No, we're doing them in the class.
So chemistry, we're going to DIT.
Yeah.
It's in Calvin Street.
Yeah. Huh? The Dublin Institute of Technology. Just the first two sentences. Yeah. got that? Yeah? Wonderful. Okay. Continue? Yeah. Now, we can't draw beautiful pictures every time. We need some symbols to make the circuit diagrams quickly and easily. So, this is the symbols we use for this course. Now, I'll just say what each one is. This one is a switch for turning on and off. Okay. This one here is a cell, and this one here is a battery. The difference we'll explain later, but it's kind of like you could have one cell, or maybe you've got a few of them, and it makes a battery. And don't worry, we'll talk about that later. This is a light, a lamp. This is a voltmeter. This is an ammeter. This is a resistor. Okay. This is a variable resistor. It means you can change the resistance. You can make more or less resistance. This is an LED diode. An LED diode is like a little LED light. You know, like on your phone. You know, the flashlight on your phone, like little LED light. And this is called a light-dependent resistor. So it means when there's more light, there's more resistance. The example, does anyone know where this one's used? This one's used on the street lights. Because when it goes dark, the lights turn on. Yeah? What's so funny?
If sector in the catching
Huh?
in catching, if you have lunch or dinner, you have to make some noisy.
Ah, I'm confused.
I even say the video.
Yeah?
They sector this line to the kitchen.
Oh! No. That's a different type of one. I know the one you're talking about. You make some noise or you move. Is it?
No,
Not this one?
just funny video.
Oh, okay. Oh, okay. You can show me later, maybe.
Oh.
Why not? You have a funny video.
No, I ever seen that.
Okay. I'm very confused. Let's continue.
Okay.
Now, there are more symbols. But these are like the basic symbols. Okay? In the exam, the most common ones are 1, 2, 3, 4, 5, 6, these 8. Sometimes they have this one and sometimes they have this one. Okay? What's also special about this is the direction. Yeah, you know this already. Do you know what this means? The triangle? So the current can easily go this way, but it's difficult for the current to go backwards in this. Okay? This one here, the current can go both ways. This one here, I didn't show it on the picture, but this side is positive and this side is negative. Okay? This side is positive and this side is negative. Yeah? So maybe you want to say that. I need you to draw these in your notebook. Switch, cell, battery, lamp, voltmeter, ammeter, resistor, variable resistor, LED diode, light dependent resistor. C-E-L. L. Cell.
1L.
I think 2.
Do you draw one?
Huh? Oh yeah, of course you need them for the exam.
Diode.
Diode. D-I-O-D-E. Yeah? Continue? Not yet. Continue? Ben? No. What class did you have this morning?
Chemistry,
Maths double, break double, physics
Yeah.
double.
Chemistry double?
yeah, double,
Everything double.
maths double.
What are you doing in maths?
The second
Second derivative?
Yeah.
and the next one.
Calculus.
Calculus, yeah. Okay. How you doing, Ben? Got it?
Yeah.
Great. You too, Khalifa, yeah? Okay, so we've seen these words already. When it's like this, we say it's series, and when it's like this, we say it's parallel. What?
No.
What?
Please continue.
Okay, so I want you to draw these two down. This is in series and this is in parallel. You drew it? Yeah. Yeah, continue. Where did you see these words before?
Parallel
Spring.
in math.
The spring, yeah.
Okay.
Okay. Huh?
No,
Yeah, the K1 and the K2. Yeah. Now, English time, a little bit of English to explain some idea here. So, one battery is not called one battery.
So
Yeah, it's called a cell. Okay? Two or more cells is called a battery.
Oh.
Yeah? So, you can say, I have a 3-volt cell. That's right. I have 2 3-volt cells, therefore I have 1 battery. That's right. I have 3 3-volt cells, therefore I have 1 battery. That's right. I have 2 batteries. Wrong.
one
Okay.
battery.
You have 1 battery. Yeah, you could say I have 3 cells. Don't say this. I have a 3-volt cell, therefore I have 1 battery. Right or wrong?
Wrong.
That's wrong. Okay. Please don't say this. Now I'm simplifying the English, but this is the idea. Now you actually maybe have seen this. Do you have a laptop? You have your laptop.
Yeah.
For example, when I was buying my laptop, you had a choice at the battery. You could get a 4-cell battery, a 6-cell battery, or a 9-cell battery. So the 9-cell battery was 3 times more time than the 3-cell battery. So I know, if you look at a battery, you might say, well, that's 1 battery. It's actually, yeah, it's 1 battery because inside it there's maybe like 3 cells or 4 cells, you know. I don't know. I think like my laptop battery here, maybe this is like.
Three lines on top of the battery, right?
Well, I don't know actually. Maybe yeah, because there's 3 lines. I'm not sure. Doesn't say. I know my battery I bought for my laptop here. I think this is a 4-cell battery. So if you broke it open, you would see 4 cells. Yeah. Yeah, maybe it says it.
But 打看。
What? He's, let me have a look, Ben.
Yeah, I broke this once, but I think that just one, just a
I
black
know.
one.
I know it looks like one, but it was maybe 4 put together. But I know it probably looks like one. But inside, yeah. But
for cells. So,
you saw 4 cells?
No, I said the battery inside the battery have maybe 4 or 3
Yeah.
cells.
Yeah. Yeah, it does. So I think maybe like this is probably 4 cells, but I don't see it there. How long does the battery last? How many hours? Yeah, so maybe that's like 4 cells. And 6 hours, maybe like 6 cells. So I think my battery's maybe only 2 cells actually, because it lasts maybe 2 hours. Yeah. So just write in your notebook, 2 or more cells equals 1 battery. 2 or more cells equals 1 battery. Now you don't just write what I say. Listening exercise.
I
2.
don't know how to spell battery.
Oh, that's fine. That's fine. What's the short word for battery? Bat.
BAT.
B-A-T dot. Like low bat.
Bat is
Animal as well. Yeah. Yeah.
Low bat.
Low bat. Low battery.
and bat is except when I do the research for baseball, there's
And also baseball bat.
Yeah.
Yes, correct. Okay, continue.
Okay.
So, here are some formulas. Current is constant. I1 equals I2. What I mean? If you have here an ammeter, and even if you have another resistor, and then another ammeter, and another resistor here, and another resistor here, and so on, the current is always the same. That the I1 here is the same as the I2.
Yeah.
When they're in series,
Yeah.
the current is constant. That's the first rule. Okay, write this down. You knew this rule, Ben.
Yeah.
Yeah. Oh yeah, Ben.
Huh?
John told me you didn't like her first principle derivative in class.
Why?
She said you talked, it was very strange and very long, and you had a quicker way.
No.
No?
First things. No.
他说导数
I know. I just. Can I just h equals 0? She said yes. But I think, we use something get a first principle. First principle.
Yeah.
And she just put some equation and get the final answer.
Yeah.
And has a h.
Yeah.
And we just h equals 0.
Yeah.
But I just remember the final equation, how to get this.
Yeah. Yeah.
The h just
No, the
proof.
simple. I just we don't learn the something.
We don't learn the proof like
Yeah.
the h.
You don't do this in
We
China?
just remember.
We
Really?
the other delta x.
That delta, yeah. Because in the exam, they sometimes ask you for the proof.
For the
That's
limit.
what John was telling you. So, yeah, you can remember the result, but sometimes they ask you for the proof. This is difficult. Yeah. Yeah. But you're right, though. You can remember the results. But you don't do this first principles in China.
No, we do.
Oh,
But
you do?
We
Oh, but you
just
forget it.
no. We,
It's not important.
we don't
No,
do
it's
the
important.
limit h.
Yeah,
H
we
goes
do
to
the
0.
delta x limit delta x
Oh, delta x is
close to
close.
0.
That's a little different.
Yeah.
Same idea. Yeah. Okay, next rule. Resistance is additive. So, for example, if you have one resistor here and one resistor here, R1 and R2, that's the same as one resistor whose resistance is R1 plus R2. Yeah? So that's the second rule.
It's constant. Is it constant or not constant?
No, they could be different. Okay? Next rule. Voltage is different and additive. So, for example, I have maybe a light here, I have another light here. I measure this voltage, V1. I measure this voltage, V2. They're different. And also, if I put one big voltmeter over both, the answer here will equal this plus this. You add them. Yeah. So the voltage adds.
So,
Yeah.
but the amp is the same.
Yeah.
So the resistance is different for
Yeah.
each.
Yeah. Yeah. Because you're right, Gav. If these were the same, like if this was 1 ohm and 1 ohm, then yeah, the V's will be the same. But usually they're different. Yeah. Okay, continue. Battery. Plus with minus causes an increase. Let me explain with a picture. So here's your battery. And the reason we call it a battery is because maybe inside there's maybe 2 cells. Okay? And you connect it with another battery. Maybe it's also 2 cells. Okay? And this is plus and this is minus. And this is minus and this is plus. If you put these together, if this is, for example, 1.5 volts and this is 1.5 volts, then together they make a battery of 3 volts. However, if you put them in backwards, the voltage minus subtracts. So, for example, if you turn this guy around, then you'll get 0 volts.
So
Yeah.
let's go. So put the battery like this.
Yeah, here, I'll show you. So, you see, they must be like this. But if you put them like this, no voltage.
No, like this. Connect.
No, when you put them inside, if you look closely, if you put them inside like this, what you'll see is there's a piece of metal here, and then not here, and then there's a piece of metal on the top
Yeah,
here,
they're always opposite.
and you would put them in upside down like this.
Yeah.
So it's like, oh no, sorry, like this. Yeah, they're going like this. So the current goes in here.
No.
Oh, sorry,
No,
no,
it's
I'm wrong.
opposite.
Sorry, yeah, no, you're right. You put them in opposite like this, so that it's like that they're touching like that. Yeah. So there's a piece of metal over the top here. Yeah. So here, I must, if that's positive, then I must put the negative touching it. The voltage adds. If it's the wrong way, it's minus. So the rule is, if you put the plus with if you put them in backwards, you minus the voltage. Okay? Alright, so now we'll do the next one. Got that? Okay. Sorry, I'm just sending an important text message.
Could you send an email by that phone?
I can. And
Video call?
I can take pictures.
Nice.
And
Wow.
and I can check bus times.
Yeah, you changed that phone.
I showed you. This phone is 11 years old. No, 12. Maybe 12, 11, 12. Still, my favourite phone. I don't like smartphones. I don't
Nokia.
like other phones.
Is that Nokia?
Nokia.
Nokia
Nokia
with the
2760.
Radio.
See? Bus times.
1, 2, 3.
Yeah. Amazing phone. Is it like... He's 11, 12 years old. It can send emails, you know? Like, how old were you when this 11 years ago?
When I was 11, I used that phone. Like when I was 10.
This exact phone?
Yeah.
This exact one?
It's not the same, but similar,
Similar
small
to-
one like this.
Yeah. And also, I like the flip. I like the feeling. You know, I don't like, you know, your smartphone. I don't like this. I like this.
It plays the snake. in
Snake
that
is
phone.
on it, correct? Yes. Classic game.
Yeah.
All right. Now let's have a look if they're in parallel. Maybe you know some of these rules. If they're in parallel, the current is different and it adds. So what I mean is, if you have a current here, I1, current here, I2, and then you measure the current here, I, this current will equal this plus this. They add. Okay, so the current, it adds in parallel. Now, do any of you know what the story is with the voltage? If it's in parallel.
It's the same.
It's the same. Yeah. So, well, actually, sorry, I was going to do the resistance next. So, if you have two resistors, there's R1, there's R2, and they're in parallel,
What's that?
you can make one resistor and OR. Does anyone know what the OR is here?
Equal. RE equal R2.
Mm-mm. Oh, no, not equal, no. The formula is 1 over R equals 1 over R1 plus 1 over R2.
What is reciprocal?
Yeah, thank you, Ben. So, if this is X, then this is called the reciprocal of X.
Okay.
Is a good word to remember.
And its opposite proportion.
只会恐惧。
Proportion? No, that's not the opposite, I'm sorry.
Proportion, I think this.
Proportion is this,
Yeah.
but that's not the opposite of this. Yeah. So, for example, Ben, I could say, this is 2, this is the reciprocal of 2. This is X, it's proportional to Y. It's not the opposite. It's not related. Yeah. Yeah. I know why you think that, but no. Okay, continue. The voltage, I think you said it, Ben. What's the story with the voltage?
Equal.
It's equal. it's the same if they're in parallel. Yeah? And lastly, the battery. So what happens if you have, for example, one here and then one here, like this? You know? What happens? We'll study that later. It's a bit complicated. We'll study that one later. Yeah.
Well, what's the difference? My question.
No, your one, if you put a battery in like this, yeah?
No, my question is that
What?
my question is that if the battery is parallel,
What?
if the battery is parallel,
Yeah.
what's the difference from the cells? Just put them in that place. What's the
That's
difference?
series.
Yeah.
Yeah.
What's the difference?
Parallel.
Yeah.
I'll draw it for you. No problem. Relax. So this one, if you look carefully, what you'll see is there'll be a piece of, there'll be usually a spring here, okay, and then usually there's a spring here, and usually there's a piece of metal here, and these are connected, and then there's a piece of metal here, and these are connected. So what happens is the current goes this way. So that's actually series because it's the same as this.
Yeah.
Okay, here, if you put a piece of metal over both and connect it, and put a piece of metal over both and connect it, then the current is like this.
It's getting bigger.
No, we'll study it later. This one here gets bigger. This one here we'll look at later.
Yeah.
So this is series and this is parallel.
Which getting bigger? Series getting bigger.
Oh, series gets bigger, yeah.
Current.
The voltage.
Oh, yeah, the voltage.
Yeah. So like if this was 2 volts and this is 3 volts, the total is 5 volts.
And this is the
Later. We'll see it later. It's not the same.
It won't change.
I mean the two battery have the same, just like two.
What are you saying? 2, 3? What are you saying?
They won't change the voltage.
No, you can have different voltages.
Okay, later.
Later. We'll do it later, yeah. Usually you use the same battery so it's the same voltage, but there's no rule that says it has to be the same. It could be different. In fact, sometimes they are different. If you have a new battery and an old battery, so if you have 1.5 and 1.5, but one is new and one is old, so maybe the new one is 1.5 and the old one is 1.49. So they can be different. Yeah? But usually you buy the same battery and they're both new and you put them both in. They're both the same. Okay. Continue. Are you sure? Okay. We'll do an example. Yeah. Stay calm. It's okay. I'll draw the picture. So you have resistor, 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 resistor. 1 ohm, 2 ohms, 3 ohms, and 4 ohms. And then here you have 5 volts. And I want to find the current, the I. Okay? So draw this, we'll do it together. Yeah. Okay? Now look,
What's the question?
find the I,
Ah,
the current. Okay, can we start? So, the first thing I will do is I'll add these two guys together. So if I add these two together, what's the total here?
Sorry.
3.
Oh, it's serious.
Yeah, they're in series, aren't they? So that's a 3. And if I add these two together,
7.
I get a 7.
Yeah.
Okay? Now what I'll do is I'll pick this up with my hand and just move it so it's over here. I don't break any of the connections, I just move it. So that's a 3 and that's a 7. Now if you look carefully, you can see,
They're parallel.
yeah, very good, that it's the same as being like this. 3 and 7. They're parallel, you're right. So what I can do is now change it into just 1. So 1 over or equals 1 over 3 plus 1 over 7. Yeah?
Yeah.
That's 9 over 21.
10.
10 over 21. So that means this one here is 2.1 ohms. Yeah? Now, look, we know the or, right?
Yeah.
We also know the voltage. What's this? 5 volts.
Yeah.
So we know the voltage. So can we know the current? Yeah, we can if we use this triangle. So the I is V over R. So what's 5 over 2.1, please? 2.38 amps. Okay? Yeah? Now, look, that 2.3 amps is only here.
Yeah.
But it's not 2.3 amps here and here. Why not? It splits. Yeah, yeah. So we now need to find the current here and here. So what we'll do is we'll go back to this picture, or even back to this picture. So you know, because they're in parallel, they should have the same voltage. Yeah? It should be the same voltage. So what is the voltage? 5 volts. Yes. So this should be 5 volts. So if I use this triangle to get the I is V over R. Yeah, so this is 5 over 3 and 5 over 7. So what's 5 over 3 and 5 over 7, please?
5 over 3 is 1.6666.
1.67 amps. And then the other one?
0.714.
0.714 amps. Now, add those two numbers together. Add them together, what do you get? You should get...
8.
No, 0.714.
1.38.
Yeah.
No. Yeah, the
2.38. 8.
8.
2.38.
Yeah. Which you should.
2.38.
Shouldn't you? Because if this is 2.38 and it splits,
Yes.
then the total here should go back to 2.38.
Yes.
So that means here in the picture, this is 2.38.
Yes.
2.38 amps. This one here is 1.67, and so is this one, 1.67, because in series the current's the same. And then this side is 0.714 amps, and this side here, 0.714 amps. So I found all the currents. Yes? Not so difficult, right? Right. Now let me see what's the pictures like I gave you. Yeah. Okay, so the first one is you have two 5 ohm resistors are connected in series, and then to a 5-volt battery. What is the current? Okay, so all of these you have to draw, except number 5, I give you the picture.
Okay.
Yeah? No, we'll just finish there. Do we have class tomorrow? We only have 1 hour today.
Yeah.
Do we have class tomorrow?
1 hours.
Yes.
1 hour.
Yes.
Right.
11 o'clock to 12.
Bring your laptop. We'll continue with the essay. What? Yeah. I want to continue with the essay tomorrow. Because we don't have class on Friday.
But our time is tomorrow.
Yeah.
11:59. We need to have the deadline.
So,
we will do maybe start at 8 or 9 until 12.
Yeah.
yeah.
I say it's the same, even though you put the deadline is Friday 12 o'clock, we will start like Friday night.
You guys are terrible. Right. Listen. Tomorrow we'll have physics, and then the first class next week is the essay. Bring your laptop. The first class we have next week. Bring your laptop. Understand? Okay.
Thank you.
When I'm set on
Someone-
Friday,
someone. Huh?
when I'm set on Friday deadline, it's the same.